Welcome to qnawire.
Hi, so over here we want to identify what are going to be the starting materials for preparing the following compounds employing a Diels-Alder reaction. So in this case, let's leave the first one up to the end since it is going to be symmetric, and let's do all of the other ones. Actually, as you can see, one intermediary step for preparation of one could potentially be three, as I will show you shortly. So for the second reagent, what we need to do is, first of all, identify where is going to be the extra double bond. In this case, this is going to correspond to carbons 2 and carbon 3 of the DN. And this is going to be 1 and 4. Thus, that means that 5 and 6 position need to be a double bond. And we need to make the separation as follows. So the starting materials for generation of 2 is going to be the following DN plus the DNO corresponding to this compound. Next up, for preparation of 3, we're going to follow the same strategy. Let's identify where are going to be carbons 2 and 3 in our structure, and we're going to make the breakage in between this section. We're going to have thus that the DN is going to be the usual one, and the DNO should be the following compound. Double bond oxygen, double bond oxygen. Perfect. Now let's go ahead and do the same thing for question 4. We identify where should be carbons 2 and 3, 1 and 4. Thus, this would be 5 and 6. Notice that in between 5 and 6, we have a double bond. Thus, the DNO should contain a triple bond for this reaction to work out. Thus, for 4, what we're going to get is our DN is going to be this one, plus my DNO. We're going to get a triple bond, and then the CO2 CH3 group on each side. Now let's go for 5. As you can see, for 5, in addition to the usual 1, 2, 3, 4, 5, and 6 carbon atoms that we're going to get, what we have are a couple of additional ones that we're going to label as 7 and 8. So we're going to break up carbon 1 and 6 and carbon 4 and 5, giving us that the DN that we're going to employ is going to be the following. This would be our DN for our starting material plus the DNO which is going to contain only a cyano group on this position. And now, finally, let's look at what is going to happen for compound 1. As you can see, compound 1 can be done from the Diels-Alder reaction of compound 3 plus the DNO. So, for example, if we start with this DN and we use as DNO this starting material, double bond oxygen, double bond oxygen. As such, we would be able to get our result. But what you may have identified is that we have two DNO in our molecule. So which one is going to react faster? Well, the one that is going to react faster is the one with electron withdrawing groups. In this case, the one with the oxygen. So we could say that this can be the starting material for generation of compound 1, or we can also say that we may consider adding the double amount of the N of DN saying that we have two equivalents of this compound plus the following DNA file to generate the symmetric reaction. And with that, it would be all. Thank you very much and have a good one.